Okay, I think that should be good now.
The instrumental variable is a concept which is relatively simple to understand, widely used, but can be very tricky in practice. An excellent example of the use of instrumental variables is one of the most quoted articles of the past decade, namely Acemoglu, Johnson, and Robinson on the colonial origins of modern economic development. The question with which the authors begin is one that has been repeatedly asked by economists since the days of Adam Smith. Why are some countries so much wealthier than others? The answer at which they arrived in earlier articles focused on the role of institutions. The stronger the rule of law, the more incentive a population will have to work and invest productively. For example, institutions can be used to explain why the average income on one side of the Rio Grande is 3 times higher than on the other. Countries such as the United States, whose governments protect property rights, are more likely to experience strong economic growth than those such as Mexico, where the state is unable to prevent predatory behavior. However, this explanation encounters 3 fundamental shortcomings. The simultaneity problem. Do good institutions bring wealth, or does wealth allow for the development of sound institutions? Measurement error. What is a good institution? How does one measure or quantify its quality? And, most importantly, the problem of contamination, or endogeneity. Institutions can be influenced by other variables such as levels of technology and education, which can have an independent effect on economic growth. In other words, there is a correlation between the explanatory variable and the error term, which violates a key precondition for OLS. For all of these reasons, we cannot use an ordinary regression. A possible solution would be to replace the problematic variable of institutional quality with one that is not subject to these same shortcomings. This variable would first and foremost have to overcome a fundamental dilemma. It must be significantly correlated with the original variable of interest, i.e., institutional quality, but not so much so that it suffers from these same shortcomings. It must be measurable without too much error. It must be exogenous, that is, it must be uncorrelated with the error term. This exclusion restriction is crucial, for if it is not respected, the results will be heavily biased. It just so happens that there is a term for a variable that meets all of these requirements, an instrument, or instrumental variable, something that is as useful as it is difficult to find. Acemoglu and his co-authors arrive at an original solution. They use as their instrument the death rate of European settlers during the first phase of colonization. Now this may seem abstract, but bear with us, we'll get you there. In places where diseases such as malaria or yellow fever caused European settlers to die in large numbers, colonists had greater incentives to set up a system that allowed them to get rich quick. Otherwise, the extended health risks would not be worth the danger. In other words, moving from square 1 to 2 to 3, they would favor an extractive economy with little regard for basic freedoms and property rights. On the other hand, looking down at the green arrow, when colonists experienced lower mortality rates, they could afford to settle for longer periods of time and create more stable and productive economies. Consequently, they required more legislation to protect their lives, liberties, and belongings from the arbitrary whims of the state. As an example, one can think of the contrast between yeoman farmers in the northeast of America and the gold-digging, slave-grabbing adventurers that plagued West African shores. This would explain the development of the rule of democratic law in the United States versus that of predatory colonial administrations in Africa. In general, former colonies often retained the institutional structures and foundations created under these early circumstances, and hence the link between settler mortality rates and modern GDP. Since the authors could not find any other link between the instrumental variable of settlers' mortality and modern GDP, other than through this effect on institutions, they assumed that they had satisfied the exclusion restriction. In other words, there's no way to go from square 1 to square 4, but to go through 2 and 3. The basic point of using an instrument is to replace a problematic variable with a model, giving you a regression in 2 stages, usually called 2SLS. In the first equation, representing the usual OLS, you find x as an exogenous variable, while in the second equation, x becomes the endogenous variable. So that you can replace x in equation 1 with the right-hand side of equation 2, like you see here. Clearly one can simplify further, but you get the main idea. Now we'll do what we just did with the equations given by Acemoglu et al. It might look far more complicated, but it's merely the same operation you just saw repeated 3 times over. In the first equation, modern GDP is regressed on modern institutions, which, as we have already seen, is somewhat problematic. In the second, we encounter the same issue due to the shortcomings of the 19th century institutional variable. The same is true for the third equation with regard to colonial population density. And so we arrive at settlers' mortality rate as the first variable that satisfies our requirements for an instrument, as previously defined. Hence, the right-hand side of the equation for colonial density can replace the variable s in the third equation, which can then replace c in the second equation. And finally, the same operation can be performed again for r in the first regression, allowing us to replace the initial problematic variable with a strong instrument. In short, it is as if the European settlers' mortality rate and the type of institutions it consequently engendered had been determined by a lottery. This natural experiment allows us to estimate the causal effect of institutions on income and to explain how countries that are otherwise similar can follow different paths of institutional development. So, how do we test the model proposed in the article? First, there is the question of respecting the exclusion restriction. However, this cannot be tested empirically, and so one must rely on the theoretical and analytical arguments provided by the authors. Second, we can verify the strength of the instrument. The authors claim that the mortality rates faced by settlers account for over 25% of the variation in current institutions, which can be deemed sufficient. Third, we can estimate that the sample is large enough for consistency to be reached, but it must be acknowledged that instrumental variable estimators are always biased. In the same way, the R2 for the second stage of 2SLS is in general of little use and in any case not reported here. Finally, whereas we could expect a larger standard error than for OLS, in this case the confidence interval is wider, implying that the use of an instrumental variable did indeed overcome a major bias. For our purposes, only panel A of Table 4, which displays the results of the second stage 2SLS regression, is of interest. We will concentrate on the first column. However, it is worth noting that the factors highlighted by the red square are those which comprise the vector of other covariates. In other words, the bold x in the previous equations. Finally, though, we arrive at the end of our tortuous journey. Thanks to the instrumental variable, we can conclude that an increase of one single level out of 10 on a scale measuring institutional quality will determine an increase of GDP per capita by 94%. In conclusion, we can say with confidence that the principal advantage of the use of instrumental variables and 2SLS in place of OLS is that it indicates more clearly the direction of causality. This has often illuminated surprising conclusions, such as the significant impact of a child's month of birth on her future salary, or the link between 14th century charities and local economic growth in present-day Italy. Nonetheless, IV remains a technique that is delicate to handle. For instance, Acemoglu and his co-authors have been widely criticized, with many pointing out that they did not properly respect the exclusion restriction, for malaria and yellow fever could directly influence economic growth independent of institutions.